Before we start animating the squirrel, we need to talk about overlapping, follow-through, and overshoot. We talk about overlapping motion when a part of a moving object is delayed compared to the rest of the object. So when we have a look at the current animation, we can see that the ball is leading the motion while the tail is trying to follow. If we track the tip of the tail, we can see that its position is offset compared to the position of the ball. This is something we will use a lot for tails, clothes, whatever is hanging on our character. But it can be used on any part of the body, a relaxed arm on a work cycle, or even on this crab character. The eyes and the crab claws are currently following the body motion with a slight delay, so it's also an overlapping motion. We can also say that those parts are dragging behind the body motion. A very important thing is those overlapping motion will communicate weight and stiffness of the material or the character you are animating. The more overlapping motion you will have, the heavier it will feel. The more overlapping motion you have, the smoother it will feel also. So it can also communicate if your character is relaxed or stressed. Follow-through is a bit like overlapping motion. It defines the fact that some part of our character are still moving after the character stops. So their motion is offset compared to the character. So basically an overlapping motion generates a follow-through. And as explained before, it will communicate the weight and stiffness of your character. We generally use overshoot when a motion has a dramatical change in its orientation, or when it's stopping. It's accelerating until it reaches its destination, and we can see that it's going a little beyond its final position and get back. And this is what we call an overshoot. Curve-wise, it's pretty easy to identify in the graph editor. We have those two keyframes that have the same value, so they are aligned on the y-axis, and we have an additional keyframe that goes a little beyond this threshold and create the overshoot motion. This is something we are going to use a lot because it conveys weight, but also speed, impact, balance, a lot of things. It can be very interesting for a punch, for example, or to give extra appeal to a fast motion. And when you combine overshoot with overlapping motion or follow-through, you can get very interesting animations. In this case, there is an overshoot on the first punch and some overlapping motion as the claws jiggle. Here I just want to show you a quick example on how you can build convincing overlapping motion very fast. When opening the Blender file, you will be directly on the action to do this exercise. With the first bone of the tail selected, I will try to spot the frame where the ball is currently moving the fastest. And it's frame 10. I will select the X rotation curve of the tail, duplicate the frame and switch them to auto clamped so that it's clean, and move the key value up so that the tail is dragging back. Since the animation is looping on 40 frames, there are great chances that on frame 30 I get the fastest motion of the ball the other way. So I will duplicate my current frame and move it on the negative side so that the tail is dragging the other way. Then, as we are working on a cycle, the first and the last keyframe must be the same, so I will press Shift D to duplicate. And to make a proper blending, I need to rotate those two keyframes using individual origin to align the starting and ending point with the current shape of the curve. Now, to make it a little more stylish and interesting, I will select those two extremes and scale them up a bit. Since the overlapping motion is an offset of the current motion, I can select all the points of the curve and press Ctrl C to copy them. Then I will select the next tailbone in the hierarchy. Make sure I only have the X Euler rotation curve selected, and I will press Ctrl V to paste the curve. Then, to slightly offset the motion, I will press Shift D to duplicate the whole curve and move it before the frame 0. This way I have twice exactly the same motion. And if I now move the whole curve by 1 or 2 frames to the right, so I'm delaying it, I will get a dragging motion for free. From there, I can copy this curve, select the next joint or the next bone in the tail hierarchy and repeat the process. Select the X curve, press Ctrl V to paste the curve. I will align it with its original shape and then offset it a bit by 3 frames. So the idea is to use the same curve for each joint, but offset it in time by 1 or 2 additional frames. Then you can play with the shape of the tail by changing the shape of the curve. Since I have a symmetrical and sinusoidal motion, I can use the 2D cursor as a pivot point. Its position is represented by the crossing blue lines. And as seen in the previous chapter, you can place it wherever you want by shift right-clicking or going into the view option and set its value. Here 0. Now I can press S and Y with all my keyframes selected to increase the amplitude of the curve, because I'm scaling the curve only on the Y-axis. So we will have a broader motion of the tail, making it look more relaxed or heavier. This is a fast, easy and cheap way to get this kind of overlapping motion done. It will sure be a little more complex on full characters, but that's a good tip.